All right, Psalm 11, let's get after it. Here we go. We're looking at our first video on geometry of parallel lines. So we're going to look at a whole bunch of different postulates and theorems that allow us to make uh, logical deductions about angles within given scenarios. So here we go. Let's start off with some vocabulary. An acute angle is an angle less than 90 degrees. So less than 90. So, little one. Obtuse is an angle that is greater than 90 degrees. So you'd see an angle like that, right? What else we got? Straight. Well, that means if you have a straight line, the angle created on a straight line is 180 degrees. And a right angle, we've heard of and seen many times, that's 90 degrees. So those are a few little angle names. And then we get to complementary. What does it mean to be a complementary angle? That means two angles add up to 90 degrees. So if you had that and you were to cut them, this one and this one are complementary angles. Supplementary is two angles add up to 180 degrees. So if you had a flat line and you had a line coming off like this, well, that angle and that angle would add to 180. And then the last one is angles that form a circle. So if you have a bunch of lines coming off, all those angles in there added together would add to 360 degrees. So we'll start there. Now, where this all starts is from what we call a postulate. So a postulate is something we can deduce to be true through basically intuitive understanding, and we can use it from there. Now, what this comes down to is a postulate of parallel lines. So if you're given that line 1 is parallel to line 2, okay, so these two lines are parallel, and they're intersected by what we call a transversal, so a line cuts through them, a few things happen. We get what are called corresponding angles. And what we end up with is we end up with scenarios that give us this angle here is equal to this angle here. And this angle here is equal to this angle here. And what else? This angle here is equal to this angle here. And then lastly, this angle here is equal to this angle here. So we get all of these scenarios, okay? We get that angle 1 equals angle 5, angle 2 equals angle 6, angle 3 equals angle 7, and angle 4 equals angle 8. And those are all things we know to be true. Now, from there, we can start proving the vertical angle theorem, but let's just go back for just a second. We call this the F rule, because what you can do is you can draw the letter F on here down your transversal, and there is an F. And the interior angles underneath your F are those corresponding angles. So this one and this one. So anywhere you could draw an F. Now, the thing is you could also draw this F upside down. Right? You don't have to follow the syntax of vocabulary. We could draw the F like this and put the arms there and there. Now you have an F upside down. If you rotated your page, you'd have a backwards and upside down F. So there and there. You could look at the same by going this way. So in all these instances, and then obviously for 3 and 7, we have an F here, backwards F. So we call it the F rule. So corresponding angles along a transversal are equal. Now it should be rather intuitive. If you were to take 2 sticks and or 3 sticks and create this scenario, it should just visually be intuitive that this makes sense because the 2 lines given are parallel lines. So it only works if they're parallel. Now let's dive on using corresponding angles to help us prove some of the other theorems, because a theorem is something that is proven using the postulate or other information. So, vertical angles. What are vertical angles? Well, these are vertical angles. Angle 3 and angle 1 are vertical angles. And then angle 4 and angle 2 are vertical angles. And the theorem here states that angle 1 is equal to angle 3, and angle 2 is equal to angle 4. So vertical angles are equal to one another. Thing is, we need to prove this. So is this true? And we can prove this using supplementary. Remember, the whole word supplementary came down to angles that add up to 180 degrees. So we know that angle 1 plus angle 2 is equal to 180 degrees. There are two angles that create a straight line. We also know that angle 4 plus angle 3 is equal to 180 degrees. But we can also look at it from the other side, and we can say, okay, well, angle 1 plus angle 4 is 180 degrees, and angle 2 plus angle 3. So all of these scenarios all equal to 180 degrees. So what you can do in this scenario is you can set them all equal to each other, but really all we're trying to prove is either that statement or that statement. So I'm going to take, okay, angle 1 plus angle 2, my top line, is equal to 180 degrees. And angle 2 plus angle 3 is also equal to 180 degrees. And if they're both equal to 180 degrees, it means they're equal to each other. That should make sense intuitively, right? 2 plus 3 is 5. 1 plus 4 is 5. So it only makes sense that 2 plus 3 is 1 plus 4. That's the same logic we're using here. And now if angle 2 is the same on both, we just get rid of it, and we've proven that angle 1 is equal to angle 3. You've proved the theorem. So now you can use a vertical angle theorem whenever you're given that scenario. You have a bit of vocabulary to put to a proof. So two angles that are vertical are equal to one another. So next we have what's called the alternate interior angle rule, which we've simplified down to the Z rule. So similar to the F rule, you need two parallel lines to be intersected. So it's given that this line is parallel to this line, and in our case, this line is parallel to this line. So what angles are interior? Interior means inside, okay? So interior angles are this one, this one, this one, and this one. And then alternate interior angles, well, it means alternating sides. So our alternate interior angles would be this one with this one, or this one with this one. So what we're saying is they are equal to each other. So essentially, if you look at the little line grid on the right, we are proving that this angle is equal to this angle. Okay, so we're trying to prove that angle 4 equals angle 5. Now, what information do we know? Well, from our vertical angle theorem, you have something here. You can say angle 1 equals angle 4. And then from our F rule, you can also say this. Right, there's my F, boom, boom. You can say angle 1 equals angle 5. And now those are both equal to angle 1, so it just must come that angle 4 equals angle 5. You have just proven the Z rule. So here's how the Z rule looks. If you can draw a Z, the angle on the insides of the arms of your Z are your alternate interior angles, and they are equal to one another. So that's another rule you'll be using when we have to start solving and proving these things. So the Z rule, the F rule, vertical angles, we got a few so far. So the next one is called co-interior. So again, what are the interior angles? Well, it's those two and those two. So what does co-interior mean? Well, it means the two that are interior together. So in this case, this one and this one, right? Here is our parallel lines. You can see that they are interior together. So what we're trying to prove here, this theorem states that angle 3 plus angle 5 equals 180 degrees. So that's what we're trying to prove for this one. So what we're going to do here is we're going to use some of our rules and some of our logic from earlier questions. So what do we know? What do we know? What do we know? Well, we know that angle 3 and angle 6 form the Z rule. So we know that angle 3 plus angle 6 are equal to not plus, sorry. We know angle 3 equals angle 6. And then we also know that angle 5 plus angle 6 equals 180 degrees because they're angles on a flat line. So then we say, okay, well, angle 6 is equal to angle 3, then that must mean that angle 5 plus angle 3 equals 180 degrees. And we have proven the co-interior angle rule. So co-interior angle rule is interior angles together, here and here, add up to 180. So the last one to consider, and then we can start solving some of these things, is angles inside of a triangle. And forever it's kind of been, you've been told, oh, angles inside of a triangle add up to 180 degrees. And that is true, but can we prove it? So here we go. We got a triangle ABC, and we've connected in a line going from D to C that is parallel to the line A to B. So we created that. Now, what do we know? We know that this angle here creates this shape, right? And from our co-interior angles, we know that angle 4 plus angle 3 plus angle 2 has to give us 180 degrees. But then we also know that from the Z rule here, angle 4 equals angle 1. So then we can take this statement and say, okay, angle 1 plus angle 3 plus angle 2 equals 180 degrees. Done, done, done. Those are my angles inside of a triangle. So now let's solve some of these things. Okay, so I need to figure out what is the angle degree of 2, and there's also a 1 here. So I am trying to determine both angle 1 and angle 2. This is also 40 degrees. So this is the information that is given to us. Now you might look at this and go, oh, well, angle 2, that's got to be 90 degrees. You cannot make assumptions like that. So how do we go about solving this? Well, these little dashed lines here and here mean that they're the same length. And these little double dashed lines here and here mean that they're the same length. So now if we look, we have, okay, here, that's a transversal, and here. So what we have is we actually have 2 times 40 degrees plus 2 times angle 1 equals 180 degrees, because those are co-interior angles, right? Now, that means 80 degrees plus 2 times angle 1 is equal to 180. And then subtract 80 from both sides. 2 times angle 1 equals 100, which means angle 1 must be equal to 50 degrees. So we just figured out that that is 50, that is 50, and we know that that is 40. So from there we can solve for 2, because we have angles inside of a triangle right here. Here's a triangle. And those angles have to add up to 180 degrees. 40 plus 50 is 90, so that leaves us 90. So angle 2 is equal to 90 degrees. So we just solved for our missing information using only logic. Didn't break any rules. Let's look at another. So we got number 3, number 2, so we need those angles. Number 1, we got a 30 degree in the corner. We're given the 90 degrees and 100 degrees in those intersecting areas. So this here is 100 degrees. This here is 90 degrees. So what do we know? Well, these are not always going to be straightforward. You're not always going to run through them and make the exact perfect decision every time. So sometimes you're going to play around with it a little bit and you're going to see what happens. But do we have supplementary, or we do? We got some supplementary going on, right? Right here we have supplementary angles, angles on a line. So if that's 100 degrees, what does that mean for that other little interior angle? Well, it means that this little interior angle here must be 80 degrees. And if this is 90, then it must mean that that is 90, because those are on a flat line as well. So we've narrowed down some info. Now in this triangle here, we have angles in a triangle which have to add up to 180 degrees. We have 80 plus 30, which is 110. So that means angle 1 is 70 degrees. So that one was easy enough. Now what we know in the next one is we know that angle 2 and angle 3 are going to add up to 90, but we don't know either of angle 2 and angle 3. But now you'll notice that you have a parallel line here and down here. So can we use a Z rule or an F rule? And we can. You can see here, you can draw a Z right there. which means angle 2 equals angle 1. And since we know angle 1 is 70, that means angle 2 is 70. And if that's 70 and that's 90, those make 160 degrees. So this must mean 20 degrees angle inside of a triangle. Boom. All right, we got another. So we got a couple parallel lines. What do we know? We got two angle 1s. Well, we need to know what those angle 1s are, right? Well, in this scenario, we're not really given much information to work with, but we know that here, okay, what do we know? We know that angle 1 plus angle 2 equals 180 degrees. We also know from the F rule here that angle 1 is equal to angle 1. Well, obviously we know angle 1 is equal to angle 1, but what do we know about the angle 1 equal to angle 1? All right, now, given a bit of information on this page that is missing from the screen, I will add it in. You are given this. You're given angle 1 equals x squared minus 25x degrees, and you're given angle 2 equals x degrees. So we're going to take some grade 10 information and start putting this together. So we know angle 1 plus angle 2 is 180 degrees. But what else do we know? From co-interior angles, we can then put this together. So angle 1 is x squared minus 25x. And then angle 2 is x, and that equals 180. So now what we have is we have x squared minus 24x equals 180 degrees. And if you can remember back to grade 10, we have a quadratic equation. So what we're doing is we're looking for two numbers that multiply to this and add to this, and we break that down. If you don't remember how to do this, you can always watch a little video on my grade 10 section, but we are factoring this out, and you get minus 30 and you get plus 6. And for that to be 0, it means either this is 0 or this is 0. So x equals 30 or x equals negative 6. Now, x equals negative 6 isn't going to work. We can't have negative values for our degrees, because if angle 2 is equal to x, we can't have that. So we know that x is equal to 30, which means what's angle 1? Well, angle 1 is 30 squared minus 25 times 30. 30 squared is 900, and 25 times 30 is 750. So we end up that x is equal to 150 degrees. This will be the hardest one you've done because it ties in some information from grade 10. But there you go. You're using these rules to help determine pieces of information. So you got your F rule, your Z rule, your vertical angles, your supplementary angles, your corresponding angles. You got all these tools to use. And when we get to section 4.2, you're going to actually start doing proofs yourself. So thank you so much, and I'll see you next time.